Again, welcome to the chemistry nautanki walah 2.0. I am from California, Mecca, and today I am going to discuss the rest part of my previous lecture. In the previous lecture, we calculated the radius of hydrogen-like atom. In formula form, it is given by Rn equals to n square into h square epsilon naught by pi m into E square, and using this value for n equals to 1, that is the first orbit of hydrogen like atom, comes out to be R1 equals to 0.529 into 10 to the power minus 10 meter equals to 0.529 into 10 to the power minus 8 centimeter, or R1 equals to 0.529 angstrom or 0.0529 nanometer, and this radius is called first Bohr radius and represented by the symbol A sharp 0 or also called A naught. So A naught equals to, or A sub 0 equals to 0.529 angstrom. Now for different values of n, we get different value of radii, like for value n equals to 2, we get R2 equals to 2.116 angstrom, that is second orbit, and similarly for n equals to 3, we get third orbit R3 equals to 4.761 angstrom etc. So the value of radii for different cell indicates that the radii are not equispaced. Now relation between Rn and R1, that is nth orbit and first orbit. So dividing Rn by R1, we have Rn by R1 equals to n square h square epsilon naught by pi mz e square into pi mz e square by h square epsilon naught equals to n square. So Rn equals to R1 into n square, or we can write Rn equals to 0.529 n square angstrom. So this is the relation between first orbit and nth orbit. Now let's calculate the total energy of electron. The total energy of the electron in any orbit is the sum of its kinetic and potential energy. So En equals to Ke plus P. The potential energy of the electron is considered to be 0 when it is at an infinite distance from the nucleus. Potential energy of an electron in an orbit is given by the work done in bringing the electron from infinite to that orbit. This amount of work done is obtained by integrating the electrostatic force of attraction between the nucleus and the electron from the limits infinity to r. So potential energy of the electron equals to integration from infinity to r into 1 by 4 pi epsilon naught z e square by rn square dr. Hence potential energy equals to minus 1 by 4 pi epsilon naught into z into e square by rn, and kinetic energy of electron 1 by 2 m vn square, or kinetic energy equals to Ke equals to 1 by 2 into Ze square by 4 pi epsilon naught Rn. So from above equation we see that potential energy is equal to twice of kinetic energy if we neglect the negative sign. Now total energy of the electron in nth orbit En equals to potential energy plus kinetic